Hello, in this module we're going to be looking at the factorial or K-way ANOVA, and this test allows us to determine if two or more variables affect group means to a greater extent than can be attributed to chance. So what we're going to be doing is basically an ANOVA test, but with more than one nominal level variable that allows us to see if the means are different and if there's an interaction effect between those two variables. So, opening up SPSS, we need to select a few of our items from our data set because all of the assumptions associated with the one-way ANOVA test are also associated with the K-way or factorial ANOVA test, and those are independence of the groups, so that everybody is independent from each other. There's a normality in the data set, so skew and kurtosis aren't too much. There's a homoskedasticity, that's equal variance across all sorts of cells. That there's an absence of correlated errors, so that any errors are systematic, any errors are random rather than systematic in dealing with your different measures. And the big sticker that we had a problem with last week, that the cell sizes between the groups need to be relatively equal. So to deal with this, again, we're going to just select some items that some countries that are of equal cell size, and that will allow us to run the ANOVA test with the relatively equal cell size assumption met. So go into select cases, and we are going to select this. If you'll recall, these three countries have the same cell size of 5, and we are just going to isolate male and female gender. We'll cut out the individuals in our sample who marked other using this. So go ahead and select this, and we'll just click continue and OK, and it worked. So now to run the test, we go to Analyze, General Linear Model, and Univariate. The same box actually that we used for one-way ANOVA last week. And we're running a very similar test. We're going to put political violence in the dependent variable box, and then country and gender in the fixed factors. This will allow us to see the differences in political violence according to country and gender. We'll go to options, and we'll get our descriptive statistics with all of these. We'll just move them all over, and we can get the descriptive statistics, homogeneity test. Remember, that'll give us Levine's test. And we'll go estimates of effect size and observed power. Okay, so that all looks good. Don't have to worry about anything else right now. We'll click OK, and here we go. As you can see, we've got just about equal sizes in male and female, equal across groups. And there are different means and standard deviations associated with male and female in each country. Here's our Levine's test that tests for homogeneity of variance. Remember, in the Levine's test, the null is that variance is equal across groups. So a non-significant test means that variance is equal. If you had a significant value here, if it was less than 0.05, then you would have non-equal variance among groups, and your homoskedasticity assumption would be violated. So we go down to this box. This is where we can actually see our levels where our different tests are run. So here's our degrees of freedom associated with each test. Here's the degrees of freedom of error. And here's the F value that is associated with each. So our country, the difference between the countries has an F value of 0.105, significance of 0.901. So a non-significant test. Gender has a F value of 2.789, and again non-significant. And country and gender together have an F value of 0.199 and non-significant. So there needs to be some care taken when you are running these sorts of tests with this K-way ANOVA. And we're going to talk about this for a little bit. So the country by gender is what's called an interaction effect. So this allows us to see that country and gender together shows that there's a difference between means. Country and then gender by itself, those are called main effects. And depending on how the test is set up, not all the time is the main effect interpretable using this test. You would just use a one-way ANOVA in the case that it was an uninterpretable main effect. And you can tell that based on the arrangement of means in different cells. So if you'll imagine that our cells look like this. We've got our countries across the top, our gender across the side, and each of these values in here, that is a cell. There's a interesting relationship that can be described here as whether it is disordinal or ordinal. In the case of a disordinal relationship, that means that the order is different. So here we can see that in all cases males have a higher mean than females. If it were the case that, for example, in the United Kingdom, they had a lower mean than females, that would be a disordinal relationship in accordance with the difference between male and female. As you can see, that is not the case. So in the relationship of male and female, it is ordinal. However, there's another way that we can check to see if it is ordinal or disordinal, and that is in the differences between country. So in the case of Australia, Canada has a higher political acceptance of political violence in men and women. In the case of the United Kingdom, Canada has a higher level in both men and women as well. That means the relationship is ordinal. So how you are looking is on each of these lines if there is a difference. So if United Kingdom was a higher mean value in a lower mean value in male than female, it would be disordinal. If there was a difference, so let's say for example Australia had a mean value of 5, then this relationship would be disordinal. It would go, the value would be higher over here, and then the value would be higher over here. So that's how you can tell if your relationships are ordinal or disordinal. I'm going to just undo, whoops, I guess I can't go back and undo what it was. It was 4 or something. So that's how you can tell if it's disordinal or ordinal. If the relationship is disordinal between those variables, the only test that you can interpret is the interaction test. The main effect is uninterpretable at this point. You can't really explain why that difference is occurring or tell how it's occurring within the main effects, because it would generally mean that there's a discrepancy between your group values, so your main effect would be different in your different cells. So you just couldn't explain it. It would be really difficult to explain. You can't do it. The only thing that you could tell would be the interaction effect. In the case of an ordinal relationship, then you can interpret the main effects. You look down here, you can then see the means for the main effects that we have going on, and then the means for, again, the interaction effects between the groups. Okay, so that is it for this module. Please feel free to leave any questions you have below, and I will answer them. I will see you in the next module.